Fugu is a new approach to AI that can rival fable and mythos. Not only that, but it can, as the first tool in the world, grow its capabilities beyond even future models. I should know. I built it. Welcome to B Explains Everything. Sakana AI released Fugu in June 2026, and unlike frontier models from OpenAI and Anthropic, it isn't the model itself, but rather a way to work with models. And no, I didn't build Fugu, but I built something very similar several years ago called Concierge, so I know extremely well how this approach works and also which problems it solves. To help you understand why Fugu is such a revolution, let's first look at the problems it can solve in the current large language model approach. Despite their almost magical ability to answer questions and generate results, large language models, or LLMs, suffer from some major drawbacks. First is the idea that they have to know everything. Not only do they have to know everything, but they have to rival the best minds in the world at every single topic. Imagine you want to hire someone, and they need to be a PhD in astronomy, a master civil engineer in bridge building, and 100% or close to accurate at diagnosing your dog's illness from a vague description of its poop patterns. And then add painting, sports, music, food, and every single topic within those disciplines. This is a massive task and means that the cost of training and running these models is staggering. Second, and as a follow-up on the above problem, no matter how well we make models, there will be topics they cannot know sufficiently. Sure, Claude might be able to plan your vacation to Thailand and even suggest what to do based on your preferences, but is it really going to have up-to-date information about the vegan street food scene in northern Bangkok? Most likely, that's too narrow a focus, so it gets left out. Even if it can have knowledge about it, chances are it won't be an expert at it. And even if it is, and this will be the third problem, restaurants and street food vendors change frequently, so what was correct when the model was trained is stale a month later. So the third problem with LLMs is that they have cutoff dates. What that means is that the model is trained on data up to a certain point. But after that, it has to go to secondary sources such as the web for information, essentially becoming a very expensive Google search bar for anything recent. Ask your favorite model about how Colombia is doing in the World Cup, which is ongoing at the time of this recording, and without looking it up, the model can't answer that. The longer this goes on, the less reliable a model becomes. GPT-4 still thinks Joe Biden is president in the US. Which brings us to the fourth problem, information accuracy. You see, you cannot untrain a fact from a large language model, and you cannot even expand it easily due to all the post-training steps to put guardrails in place and tune its performance. If you train GPT-4 to know that there's a new president in the US, you would need to redo all the post-training work for the entire model to keep the same model performance in both quality and speed. So most often, it's cheaper and faster to train a new model, even if that means millions or even billions of dollars in cost. You can't just add one piece of data when an election result comes in or there's a new version of your favorite programming framework. You need to retrain everything every time, meaning that small updates never make it into a model. Finally, and the fifth problem is that despite training on all the public information in the world, no AI lab will have access to your own data. Whether you are a person with your FaceTalk friends list and their information, or you're a big company with proprietary secrets, no AI lab will be able to train its main models on that data. This doesn't even take into consideration whether they are allowed to do so. There's simply no incentive for OpenAI and Anthropic to spend $1 million extra to learn whether you think Lisa and Frank from your high school have feelings for each other. Even with the billions of dollars that the top US AI labs have available, they cannot solve these problems because of how LLMs fundamentally work. That's where Fugu and Concierge come in. What if instead of training one massive model that has to be an expert at everything but is stale within a month, what if we trained only the parts that need to change? Not just that, but imagine we can train only the parts that are needed instead of the whole model. That would mean we could make a model be an expert on any topic, including current vegan street food options in northern Bangkok this week. This is the way that Fugu and my own Concierge work to overcome the limitations of static frontier models. Instead of just asking fable or mythos a question, Fugu can use different models for different purposes. You may not need the hacking capabilities of mythos to go on vacation, and if you do, please invite me because that's a vacation I want to join. Thus, Fugu can choose a less capable hacking model and a more capable vacation planning model to answer your query. Fugu does this mainly with a pool of static models. As a service, it can learn how to route your query to the best model for that purpose, and by doing so, it gets better capabilities on average because each model, even the static ones, is better or worse at some queries. What's more, the pool of models is not static itself, so when new models come out, Fugu can add or replace existing models with new ones, meaning that it will retain its capabilities as new models come out. Concierge took this a few steps further in 2024 when I first made it. It can do the same thing as Fugu does, but Concierge also had some additional capabilities. These capabilities came from Rob, an AI agent I built in 2022 that could teach other agents new tricks in game development. Rob had that capability because when we started using AI as virtual team members in game development and mob games, AI was still in its relative infancy. There were lots of capabilities that AI couldn't do, such as creating 3D models, 2D animations, good music, and so on. When Rob was asked about these capabilities, he would add them to a backlog, and then, when AI could do those things, Rob would then learn and give those capabilities to other AI agents on our virtual team. As such, Rob, which we built in 2022, could learn things that are only now becoming possible. Concierge took this a bit further. It doesn't just learn new things, but it could even create the training of new, dedicated models. So, if there are no models that are experts in that vegan food scene in northern Bangkok, it could set up the training of a small language model that's solely focused on that particular topic. That small language model could then, through a subsystem called Professor, go through a training program to gather data to become the expert on that topic. In other words, Concierge had true self-training for models, or in this case, a very advanced agent, to gain new capabilities that nobody knows it needs yet. Concierge was a one-man project that I never finished or could afford to run long enough to be impressive, and frankly, that was never my intention either. However, Fugu does the majority of what Concierge could do in flexible model routing. That's how I know that, if they do this correctly, they will be able to match or exceed the capabilities of any current and future models. If you want to learn how to build agent systems like these, you should consider one of my books on agent development and also follow this channel. So click like and subscribe and ring my bell. Then you can comment if you have questions and share. You know what? You know how this works now? You've been on the internet before. I trust you to know what to do, and if not, maybe ask an LLM. This has been B Explains Everything, and I wish you a good morning, evening, afternoon, night, or whatever it is where you are, and I hope to see you in the next video.